This is lesson 1.4. It's called Tutor Time, using tables to solve problems. I will say that a really, really big standard for you guys this year is being able to use tables to solve problems, fill tables in, pull out unit rates from tables, um, scale up and scale down using tables. So there's a lot of information that you need to know um, in the basis of using tables and using tables to extract information from those tables. So in this lesson, you will use tables to represent equivalent ratios and to solve problems. Okay, so it was not too long ago that if you needed help with homework or grasping a concept in one of your classes, you would either stay after school and speak with your teacher, or you may have gotten the help of a tutor. However, technology has made tutoring a snap. For many struggling students, accessing a tutor online is much easier and more convenient than traveling to a physical location. And tutoring in the school studies is not the only way that is in demand. Up and coming chess players used to rely on chess coaches or teachers in their city or town, but you were out of luck if your town did not have a chess teacher. Now, aspiring chess players can access almost any chess teacher available in the entire world. But of course, academic tutoring or chess coaching are not just for free. Generally, there's a fee. Sometimes chess coaches charge up to $80 per hour for their services. What do you think academic tutors charge their students? Have you used online tutors before? Well, just to use this as a way or as an example of a unit rate, we have $80 per 1 hour. And this is a unit rate because we have one as one of our quantities. We know it's a rate because we are comparing dollars to hours. So we have two different units that we're talking about. Therefore, it's a rate. It's a unit rate because one is one of its quantities. So using tables to scale up and scale down. A Girl Scout troop of 16 members sells 400 boxes of cookies in 1 week. Assume that this rate of sales continues. Write the relationship between the number of boxes of cookies and the members in the situation as a rate or a ratio, and explain your reasoning. If we look down in our table, we can see that 400 boxes for 16 members. Well, if I were to write this as a ratio, it would look something like this. I would say that this is a rate because we are comparing two different quantities or two different units. So we have boxes and we have members, therefore it is a rate. So the relationship So again, the relationship is a rate because the units are different. We're comparing different units. We have boxes and we have members. Moving on. So I'm going to give you a second to try to think about how we might complete the table. Once you have an idea, you can unpause. So in order to use scaling up and scaling down, we have to think about the numbers that are given to us. So the numbers down at the bottom are the numbers that are given to us. So we have to think about, we're going from 16 to 8. I hope you're thinking about, how we could have done that. In this case, we would want to use the scaling down method because our number got smaller. So if we go from 16 to 8, that means we had to divide by 2. So therefore, we would divide by 2 using 400. 400 divided by 2 would give us 200. The next one, we're going from 16 to 32. Well, 16 times 2 gives me 32. Therefore, 400 times 2 gives me 800. This is an example of scaling up. Now, these first two are really nice numbers because we first divided by 2 and then we multiplied by 2. There's not a nice whole number that we can multiply 16 by to get 24. So I want you to take a second and think about what you could do in this situation to figure out what you multiplied by. Okay, so now that you've had a second to think about it, one strategy to use would be to take this 24, divide by 16. That's going to give you your scale factor, or what you're multiplying by. I know we haven't talked about that word scale factor yet, but we're going to get into it when we get into our geometry unit. So if you did 24 divided by 16, that gives you 1.5. That means that I take 16 times 1.5 to give me this 24 right here. So I'm going to do the same thing with the 400. So I do 400 times 1.5, and that's going to give me 600. I'm going to let you take that last one and then pause it and come back and see if you got it correct. Okay, so this last one is scaling up as well because we took 20 and we divided it by 16. That gave us 1.25. So that means we took 16, we multiplied by 1.25 to get this 20 right here. So if you do the same thing for the 400, we take 400, we multiply by 1.25. That gives us the 500 that we have here. Part C asks us to determine the unit rate for this situation. So what we're going to do is you should know that a unit rate needs to have 1 as one of its quantities. So we start out with our original rate here, and we're going to scale down because we need 1 as one of its quantities. So, and this guy says 1 needs to be in the denominator, so we're going to keep that in mind. So anyway, so to go from 16 to 1, it's a simple division by 16. So if we divide by 16, that's going to give us our 1 here. Well, what we do to our denominator, we must do to our numerator. So in order to get this, we're going to say 400 divided by 16. That's going to give us 25. So the unit rate in this situation would be 25 boxes per member. Next, it's asking us to use the unit rate to calculate the number of boxes of cookies 50 Girl Scouts could sell in a week, and then explain yourself. So in order to set this proportion up, you have to think about what they're asking you for. So we would start with our unit rate of 25 boxes per member. And this is telling us that they want to know 50 members or 50 Girl Scouts. So when setting up a proportion, you have to put the units that go together in the same places on your fraction. So because members is in the denominator on this fraction, we would have to put the 50 members on the bottom here. And this is a simple task of scaling up. So we're going from 1 member to 50. So you should be thinking in your mind that you have to multiply by 50 here. So what you do to your denominator, you must do to your numerator. So I'm going to multiply by 50 on top. And that is going to give me 1,250 boxes. So I would simply write out 50 Girl Scouts would sell 1,250 boxes In this next problem, it says use the unit rate to calculate the number of Girl Scouts that it would take to sell 575 boxes. So in this case, we see the boxes. We know that our boxes for our unit rate is in the numerator position. Therefore, we need to keep those units together in our numerator. So we have 575 boxes in the numerator. In order to figure this out, you either know what 25 times something equals 575, or you can always divide. If you divide 575 by 25, you get 23. So that means we multiply by 23 here to get this. Therefore, we need to multiply by 23 here to get what the new denominator. So in part F, it says, does having the unit rate help you to answer these questions? Well, since we've started out with the unit rate in each situation, it would definitely be a yes for me. So the unit rate makes it simpler because all I have to do is multiply or divide. In these two cases, we scaled up on each one. So it definitely made it much easier for us to use the unit rate. And again, that is scaling up or scaling down. Number 2, about 13 people out of 100 are left-handed. Write the relationship in this situation as a ratio or a rate and explain your reasoning. Well, in this situation, we have 13 people that are left-handed. And we also have 100 total people. I hope you're thinking to yourself, this should be a ratio because they both deal with people. If we have people in both instances, in both the numerator and the denominator, so both units are the same, then it's a ratio. If we have two different units, then it's a rate. But in this case, we both have people, or we have people in the numerator and denominator, so therefore it is a ratio. Complete the table with the number of people you would expect to be left-handed. Well, again, we're going to use our skills of scaling up to figure out how many people would fit this. So if we are trying to go, we're using the numbers that they are giving us in the table to figure this out. Again, just like we did in the last problem. So we are starting with 100. We're ending with 1,000. I hope you're thinking to yourself that all we're doing is multiplying by 10. Therefore, that's what we have to do for the numbers on the top. So we're doing 100 times 10 to give me 1,000. 13 times 10 gives me 130. In this next situation, we're not scaling up, we're scaling down. So therefore, we got to figure out what we divided by. Well, going from 100 to 25, you're simply dividing by 4. If you didn't know that, you could take 100, divide by 25, and it would give you 4. Therefore, we need to take our 13 here and divide by 4. So 13 divided by 4 gives us 3.25, but we all know that you can't have a fourth of a person. So this one is approximately 3. Part C, complete the sentence that states another equivalent ratio or rate that you did not use in the table. Explain your reasoning. I'm going to let you do that one by yourself, and I'll write down an example, and you can come back and check yourself. In my example, I simply used the scale factor of 100. So I said 13 times 100 gave me 1,300. 100 times 100 gives me 10,000. 3 robot lawnmowers can mow 5 regulation football fields in a day. Write the relationship between the mowers and the football fields in this situation as a ratio or a rate and explain your reasoning. I'm going to let you complete this entire problem. I want you to pause the video. I want you to use the skills that we've learned thus far and fill in what you think the answers are, and then come back and check yourself. Okay, a color printer can print 7 color photos in 1 minute. Again, I want you to use what we've talked about, the answers from the last 3 problems. Come up with what you think the answers are and then check yourself. Problem 5. Tony needs a rate table for his tutoring job so that he can look up the charge quickly. Complete the rate table. Well, this right here gives you the unit rate. From there, you can scale up to find however many hours you'd like to know. So for instance, if we went from 1 to 1.5, well, we would just have to take 1 times 1.5 to get 1.5. So 2.5 or $2.50 times 1.5 gives you 3.75. There's only one problem on here that you're going to have to scale down because you're going from 1 to 1/2. So you're taking half of this. So you would take $2.50. If you took half of that, that's $1.25. I'm going to give you some time to finish this table, come back and check yourself. Hopefully you're feeling pretty good about the table at this point. Part B asks you to describe how you use the table to determine each tutoring charge. Then use the table to determine the tutoring charges for, and then it gives you 3 different things. You will see problems like this where you're actually having to fill in a table, or you'll see them like this where it's just kind of one problem out at a time off to the side. So I'm going to give you a few minutes. You're doing exactly the same thing as you were doing. So I want you to fill in I, 2I, and 3I. So on I, you could simply add the charge you got right here for 4 hours to the charge right here for 2 hours. So sometimes it's quicker and more time efficient to use what you already have in a table to answer questions rather than recalculating everything. Here are the answers for the last 2 problems on this page. You also need to include an explanation like I did here, but I just didn't write it all out for you, but you need to write that on your own. Part C, Tony made $21.25 last weekend. How many hours did he tutor? Well, in this case, we could write the unit rate again. So we had 1 hour, and we had $2.50, and we need a total dollar amount of $21.50. Then we're going to use our scaling up, what we learned about scaling up. Notice how both dollars are in the denominators and both hours are going to be in the numerators. So we could take $21.50, divide by $2.50, and I made a mistake right here. Let me rewrite this. My eraser is not working very well, so I'm just going to scribble this out for now. This should say 21.25. And if we did 21.25 divided by 250, you would get 8.5. So that means we multiply 250 by 8.5 to get this. So therefore, we're going to have to do the same on the top. And that's going to give us 8.5 hours as our answer. You could have also, instead of using a proportion and multiplying or finding a, what you're multiplying by here, you could also use the table, and you could have seen that he made $10 for 4 hours and then doubled that to get $20 for 8 hours, and then you see that he earned $1.25 for 0.5 hours, so you would just add the 4 plus 4 plus 0.5. All of that information is found in the table. Part D, if Tony made $125 for 1 week of tutoring over the summer vacation, how many hours did he tutor? I want you to try to write a proportion, set it up, and see if you can solve it. So hopefully you got 50 hours for that one. Number 6, Haley's cat eats 3 large cans of food every 8 days. Determine the answer to each question. Explain your reasoning for the method you chose. How many cans of food will her cat eat in 24 days? Well, first we need to set up our rate here, because our rate is 3 large cans in 8 days. So we have 3 cans, 8 days. From there, they want to know 24 days. So again, because my days are in the denominator here, I need to put my days in the numerator, or the denominator on this side, and then we're trying to figure out what this is in the numerator. You can cross multiply, or you can use the same scaling up methods we've been using. You should know that 8 times 3 gives me 24. So 3 times 3 would give me 9. So it would take her 9 cans for 24 days. Part B asks, how many days will 1 large can of food last? How did you determine your answer? Well, you can do this several ways. The way I think is easiest is simply what we've been doing. We know that 3 cans will last 8 days. And we want to know how much 1 can would last. We don't know this. So again, because I have cans in the numerator here, I need the cans in the numerator over here, because we want to line up our units. 3 divided by 3 would give us 1. So we need to do 8 divided by 3 to give us 2.6 repeating, or 2 2/3 days. How many days will 20 large cans of cat food last? Well, again, you're going to follow the same process. Come back and check your answer. Okay, so go ahead and check yourself. We're going to move on to that last problem. So 1 pound of bananas costs 64 cents. Describe the strategy you used to determine the cost of each. So what is the cost of a half of a pound? Again, you want to set up, you know that if 1 pound is 64 cents, half of 1 would be half of the 64 cents, which would give you 32 cents. Again, I'm just writing out answers. You need to write complete thoughts in your math book. Next, we have 1 pound, 64 cents. We want to know about 2 pounds. Well, 1 times 2 is 2, so 0.64 cents times 2 gives me $1.28. So 2 pounds would cost $1.28. That's a 2. What is the cost for 2.5 pounds? I'm going to let you go ahead and try that one. Check yourself. If you're feeling good about it, then you need to just start the skills practice that is attached to your work plan.